Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 9th grade topic, creating linear equations from points. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you see today, or even your own homework, you can always put in the comment box below, or visit me on my Facebook page, @Tutor Me Sempai, and tell me all about it there. Today's video should be a rather short one, so leave a like, smash the subscribe button, and let's get started. Similar to my last video on how to create linear equations from graphs, we're going to need two things in order to accomplish our task for today. Now, before we get started, I really recommend you check out that video because that is going to show you that we have a lot of similarities to what we're going to cover today. Understanding both of these videos will give you a better shot at creating your linear equations regardless of how they give it to you, whether it be by graph or by points. A plus is understanding how to do both will reinforce your knowledge of the other. So check out both videos, this video and my previous video, you can check it right up here, and make sure you understand how to do it both ways. If you've already seen my previous video, what's needed is going to look very familiar. The first thing you're going to need to know is your slope-intercept form. You have to remember your slope-intercept form. And if you don't remember it, it's y equals mx plus b. And what is m and what is b? Well, m is going to be your slope, and b is going to be your y-intercept. So the first thing is knowing your slope-intercept form. You have to remember this. The second thing is you have to be able to solve for the unknown parts of your slope-intercept form. What are those unknown parts? Well, we just talked about it. It's going to be your slope and your y-intercept. So this is your number 2. This is what is going to be needed in order to create your linear equations, whether it be from graphs or whether it be from points in a table. Now, if you're looking at this and you're thinking to yourself, this does not describe a linear equation, this is something else. You may be working with a different definition than I am. When I talk about linear equations, I'm talking about any equation that results in a straight line when drawn. That is what I'm considering to be a linear equation. I talked about this more in an earlier video when we identified linear functions versus nonlinear functions. You can check out that video up here as well, and you'll see that working definitions really does change the game, so making sure we're on the same page is a must before we get started. Now that we know what's needed, let's actually check out some points and create our linear equations. This is going to be our first example for today. We have a bunch of points here given to us from a table. And we want to be able to create a linear equation from these points. Remember, the first thing we have to do is recall what our slope-intercept form is. You have to recall that. You need to know what that is. So I wrote that here so we don't forget it. We also need to be able to solve for our unknown parts of the slope-intercept form. And that's going to be your slope and your y-intercept. So I put those here so when we find them, we can jot them down and then plug them back in order to create our linear equation. So how you go about this is going to be really familiar if you already know how to do this based off of a graph. It's actually probably going to be a little bit easier because with a graph you have to choose your points wisely, whereas they already give you all the points necessary here, way more than you even need in order to create your linear equation. So let's start with the easiest one first, your y-intercept. In this case, it's going to be easy because they already give it to you. Remember, your y-intercept is going to be whenever x is 0, what is the y value? That's where your graph is going to intersect your y-axis. So what is y when x is 0? You notice y is 2, so your y-intercept is going to be 2. Now that we know what our y-intercept is, we need to find the slope. Now your slope is just going to be rise over run, which is just going to be your change in y over your change in x. So remember, rise over run is going to be how your y is changing over how your x is changing. And what do we mean by changing y's and changing x's? Well, going from one x to another x or one y to another y is going to be a change in y or x. So rise or run is going to capture that, and when it captures it, that's essentially giving us our slope. Now, this is where you have a lot of freedom. you can pick any 2 points. Unlike with the graph where you don't want to pick the wrong point, there really is no wrong point when you have a table of points here. Let me show you an example. Let's say we want to find the slope from these 2 points here. So your change in y, let's say change in y here is going to be, so change in y equals 2, because we're going to start from our smaller one. So 2 minus a negative 4. And your change in x is going to be 0 minus a negative 2. So if you're starting here and you're going here, so going more positive on the x-axis, this is going to be your change in y over change in x. Now we're going to simplify this. This is just going to be 2 minus a minus gives us a plus 4 over 0 minus a minus is going to give us a plus 2, which equals 6 over 2. Now we can simplify this. What do you get when you simplify this? Well, that's going to be 3. So we know our slope is going to be 3. However, I said there's no wrong point to choose. You can pick any 2 points. So let's do it using our extreme points and see if we get the same slope. We chose these 2 because they were right next to each other and they were easy. How about our extremes? So our extremes are going to be up here and down here. We're starting here and we're ending up here. So our change in y is going to be starting from all the way at negative 4 going up to 20. 20 minus a negative 4. And our change in x is going to be starting at negative 2 and going all the way up to 6. So 6 minus a negative 2. Now what is 20 minus a negative 4? Well, that's going to be a 20 plus 4, so 24 over 6 minus a negative 2 gives us 6 plus 2, which gives us 8. And what do you get when you simplify 24 over 8? The same 3. So just like I said, there is no wrong point to choose when trying to find your slope. Pick any points and just make sure you reduce it down to its simplest form. Unlike a graph where you could choose the wrong point because you have to end up guesstimating, you don't have to worry about that when you have a table full of points. So now that we know our slope and our y-intercept, let's plug them both into our slope-intercept form in order to create our linear equation. Always remember, an equation needs to have an equal sign, or else it's just an expression. So y equals, because we're doing linear equations, not necessarily linear functions, so you don't have to worry about that whole f of x thing. Linear equation, so y equals m, which is slope, so that's 3x plus b, which is 2. And this is how you're going to create your linear equation when you're giving a bunch of points within a table. Let's try another example. This is going to be our example 2 for today. Now we have a new set of points within our table, and we want to do the same thing we did in our previous example. Find our slope, find our y-intercept, plug them into our slope-intercept form, and create our linear equation. However, unlike our first example, finding the y-intercept is going to be a little bit more work here. They don't just give it to us in our table of points. So we have to figure it out. So we're going to find slope first and then come back to our y-intercept because I want to give you 2 ways that you can easily find that y-intercept whenever you don't put it directly into your table. So remember, your slope is just going to be your rise over run, which is just going to be change in y over change in x. And just like we talked about in our last example, there really is no wrong point. You can do the points next to each other, you can do extremes, anything in between. As long as you have 2 points that you're going to, and it's not going back to the same point, you can easily find your slope. So for convenience sake, I'm just going to use these 2 points because they're next to each other. And they're small numbers, so it's easy math without having to worry about any kind of mistakes. So our change in y is going to be, well, let's say we're starting at 2 and we're going to 7. So we end up at 7. We start at 2, so 7 minus 2. Change in x is going to be, well, we start at 3, we're going to 6, so we end at 6 minus 3 where we started. And what do you get when you get 7 minus 2? Well, that's going to be 5. Now, what do you get when you do 6 minus 3? That's going to be 3. So our change in y, we're changing x, or rise or run, or the slope is just going to be 5 over 3. Now let me rewrite that because that looks a little bit illegible. Can't really understand what I wrote right there because I'm trying to squeeze it in. But 5 over 3 is our slope. 5 over 3. Not much better, but a little better. 5 over 3. Now, just to drive home the point one more time, I'm going to do the extremes again. Remember, it doesn't matter which ones you choose. However, I want to drive it home. So instead of 7 minus 2 and 6 minus 3, we're going to do 22 minus 2 and 15 minus 3. Now what's 22 minus 2? Well, 22 minus 2 is going to give us a 20. And what's 15 minus 3? 15 minus 3 gives us 12. Now we want to reduce this. Well, what goes into both 20 and 12? 4. 4 goes into 20 5 times, and 4 goes into 12 3 times. So you see, it doesn't matter. We get the same exact slope that we just found, 5 over 3. Now that we found our slope, let's move on to finding our y-intercept. Remember, I said I wanted to give you 2 ways that you can do this, and both ways are going to be pretty easy depending on what you have in your table of points. Let's say you have something like this. This is going to be very easy to do the first way I'm going to show you, and that is just keep adding numbers into your table in order to find your x equals 0 value. What do I mean by that? So let's say we have 3. I'm going to just rewrite this here. 3, 2. That's going to be our xy point. We want to go backwards until we get our x at 0, right? So this is x and this is y. We want to go backwards until we get our x at 0, and then we'll figure out what our y-intercept is. I said this is going to be easy for this one because you see our change in x was just 3. So going backwards 3 gives us 0, right? We start at 3 here, going backwards 3 gives us 0. And we saw our change in y was just 5. So using our slope to go backwards, we can figure out that 2 minus 5 is going to give us what? Well, this is going to be a negative 3 here. So just going backwards, right? Going backwards using our slope from our first point, we can easily find our y-intercept to be negative 3. Now, it isn't always this easy. Like I said, this worked out very well just because of how the points were given to us. But this could also be not the easiest way and probably more work than is worth, depending on what you have to do. The second way I'm going to show you is going to be a sure win way no matter what points they give you. As long as you have your slope, you'll be able to find your y-intercept. And let me show you how. So assume that we don't know what our y-intercept is. We want to plug in the slope and keep everything else as is in our slope-intercept form. So we start with y equals our slope 5 over 3 x plus b. So we have what looks to be very similar to what our equation is going to look like. However, we don't know what b is. Now we want to solve for b. And in order to solve for b, we have to fill in a random x and y. Now, when I say random, it's not truly random. I want you to pick a set of points here. Any points. It doesn't matter. You can pick this point, 3, 2, 6, 7, 9, 12, 12, 17, 15, 22. I don't recommend you pick points outside of what they give you because if you happen to find more points, you could be wrong. Your math could be slightly off and you don't want to do extra work based on incorrect math. So stick to the points they give you and plug them in. Once you plug them in, b is going to be the only thing that you don't know. So therefore, you can solve for that b, and that will be your y-intercept. Just to keep things simple, I'm going to use this first point here. Now we have y is going to be 2 equals 5 over 3 times 3 plus b. This is going to cancel out because you have one on the top and one on the bottom. So you're left with 2 equals 5 plus b. Well, you have to get b by itself. So subtract 5 from both sides. 2 minus 5 equals b. Well, what's 2 minus 5? Well, 2 minus 5 is going to be a negative 3 equals b. So now we see it doesn't matter how your points are. As long as you know your slope, you can find your y-intercept. Now you see why I want to find slope first and then find our y-intercept. But now that we know what our slope is and what our y-intercept is, let's create our linear equation. Once again, you need to have that equal sign. So y equals our slope, 5 over 3x, and instead of plus, we have a negative intercept here. So we're going to say minus 3. So y equals 5 over 3x minus 3 is going to be our linear equation for this set of points here. So I hope you follow into the examples, and I hope you see that creating your linear equations from your points is going to be very similar to creating your linear equations from your graphs. However, if you have any question about what we saw today or even your own homework, you can always put in the comment box below or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found this video helpful. And if you found it helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.